students, I would like to introduce you to the course Physics 100C that I will be teaching this semester. This is a lab course and therefore fulfills the requirements for general education. It's very basic and simple, and therefore, even if you don't have a background in physics, you're invited to study. I'll start with a brief introduction. I did my PhD at the Vienna University of Technology, TU Wien, under the supervision of Professor Helmut Rauch. I have the honor to be his student and team member. Professor Rauch is an eminent scientist in Europe, the recipient of the highest awards in physics. He demonstrated experimentally as a pioneer that neutrons, which are massive particles, can behave as matter waves, just like photons. I am also a research fellow at these European institutions. I have a strong affiliation with FCC. I have served FCC at various positions. Also, as a chair of the department, I played a foundational role in the postgraduate research program. During this time, I established the research labs for postgraduate students, and I'm very proud that successful theses have been produced in these labs, and the program is running successfully. Learning outcomes, we would like students to be familiarized with the concepts of physics and hence develop the skills to solve problems using these concepts. This will lead to an understanding of the applications of these topics that we study in later in life and in their professional careers. Now, the teaching methodology involves discussions, so problem solving, assessments, of course, and I will be doing labs since this is a lab course. And if we have the possibility to do physical labs, that would be fine. Otherwise, we will be working on virtual labs. All information will be shared and students will be encouraged to participate. These are some topics that we will be discussing. So you can see they start from the very basic, simple topics towards the smallest particles in the universe and then the biggest objects in the universe. So physics is in everything. It addresses all the phenomena taking place in the universe. You can see we started with motion and measurements, and it's about waves, and then telecommunications, global warming, climate change, fiber optics. Physics is behind all of these inventions, and therefore an understanding would be very useful and beneficial. So inspiration, we all are familiar with these scientists and the powerful work that they've done, even if we're not physics majors. And these are some news that everyone has come across. Again, you don't have to be a physics major, but you will be familiar with these important happenings in the field of physics in the recent years. So I showed you some older Nobel Prizes and what we have achieved in the world today, and then some current events as well. So again, whatever your major is, physics is very relevant for you as it will help you work in multidisciplinary, interdisciplinary projects, which is what we need today. So you can be a computer science major or a bio major or an environmental science major, or whatever your aims and goals in life, you will have to have a basic understanding of physics. It will always be useful for you. So I have given some examples over here, and this is the power of liberal arts education. You have the opportunity to learn this. So these are some famous institutions of physics around the world, and you are all familiar with this, even if you're not physicists. We know about CERN, where fascinating experiments are performed. We know about the work at NASA. We see the images almost every day. And I have also had the honor of working and collaborating and performing experiments at some of these institutions in Europe. So therefore, there's a very interesting journey we can go on together towards learning physics. These are some former students. And these are some links that you can explore further. I look forward to seeing you in class. Thank you.